In this episode of Remote Trigonometry, we will be going over some other common identities. We defined an identity in an earlier video as an expression that is true for all possible defined values. Any trigonometry textbook, and actually calculus textbook for that matter, will have a chart somewhere in it. It might be on the front cover. If it's not directly on the front cover, it might be within a few pages. It gives a catalog of different identities. These are just a finite number of common identities that come up fairly often. I mean, technically, there's infinitely many identities. You just need to write an expression down that's always true for all possible defined values. But any textbook that's trigonometry or calculus is going to give you a reference of some common identities that we use a lot. I'm going to go over some of the identities and kind of show how they are all related. That's what's so wonderful about trigonometry, is that so many of the ideas just come full circle. They're all related to each other. So we're going to start with the equation of our unit circle, and the equation of the unit circle is x squared plus y squared equals 1. And remember, cosine is the x coordinate on the unit circle. Sine is the y coordinate on the unit circle. And if we think about how cosine is x and sine is y, and we plug them into our equation of the unit circle, cosine is x, so cosine squared, plus sine is y, so sine squared, should equal 1, because that's the equation of the unit circle. So this identity is an important identity called the Pythagorean identity, because it basically is true because of the Pythagorean theorem. Now, from that identity, we can actually prove a few others. So let's write down the Pythagorean identity. Cosine squared theta plus sine squared theta equals 1. And then let's divide both sides of the equation by cosine squared. Remember, it's algebraically legal to do something as long as you do the same thing to both sides. So if I divide this side by cosine squared, I need to divide every term by cosine squared. And then cosine squared divided by itself will equal 1. Sine divided by cosine is tangent, so sine squared divided by cosine squared will be tangent squared. And 1 over cosine is secant, so 1 over cosine squared is secant squared. That's another famous identity that gets used a lot. 1 plus tangent squared is equal to secant squared. We can come up with another common identity by, instead of dividing both sides by cosine, we can divide both sides by sine squared. So again, cosine squared plus sine squared is equal to 1. If I divide both sides of the equation by the same thing, sine squared, I end up with cosine over sine is cotangent, so cosine squared over sine squared is cotangent squared. Sine squared divided by itself is 1. 1 over sine is cosecant, so 1 over sine squared is cosecant squared. So cotangent squared plus 1 is equal to cosecant squared. That's another identity proven from the Pythagorean identity. So the three of these together are kind of included as the Pythagorean identities, although this is really the main Pythagorean identity.